I am a visual learner and I'm a visual teacher. So in order to explain this, I decided to graph the ordered pairs. So I'm going to start with f of x, and it's easier for me to see the ordered pairs vertically instead of the way they wrote it horizontally. But I'm going to put f of x in red. So the point -2, -2 goes right there. It is directly below the -2 on the x-axis and across from the -2 on the y. If you've ever played Battleship, you know, like B3, you move over horizontally to the letter B and then you go up 3 and plot your battleship. It's the same kind of thing here. You would move horizontally first, and you always start at the origin. The origin's right here. So I would move 1, 2 to the left and then go down 1, 2 and plot my point right here. That's how I graph points. Okay. The next point is -1, +1. Oh, I'm sorry, I copied that wrong. -1, -1. There we go. Which would be right here. Then 0, -3. Now when I'm at the origin, that is 0, so I just go straight down 3 to here. Then I've got 1, +1, which is there, and over 2, up 2, which is there. And then I'm just going to connect the dots so I can get a visual on what this graph looks like. Okay. All right, so that's f of x. Now I'm going to pause and I'm going to do g of x, and I'll do that in blue. All right, so here's g of x. -3, -2 would be here. -2, -1. -1, -3. 0, 1. And 1, 2. And now I'm going to connect those dots. Not doing a very good job. Sorry about that. Now, I can already tell that the blue graph has moved one place to the left of the red graph. And if you read through the practice activities and you read how it talks about the way graphs transform, if you move left and right, which is a horizontal move, the function, let's see, they said, I'm trying to remember what letters they used. Whatever f of x is, then g of x would be f of x minus h. This is for a horizontal move. And if h is positive, it moves to the left. If h is negative, it moves to the right. Hang on a second. I think I said that backwards. If h is negative, it moves to the left. If h is positive, it moves to the right, which makes sense. However, since we are moving to the left, when I go from, let me use yellow on this. Whoops. When I go from this point to this point, or from this point to this point, or this point to this point, I'm going from red to blue, I'm moving to the left 1 unit. So that would be a move of -1. So my h is actually -1. So what I have is f of x minus a -1, which gives me f of x plus 1. So that's my answer right here, f of x plus 1. That's the transformation. Okay, so now I'm going to pause again, and I'm going to do h of x in green. Okay, so I've removed all of the g of x stuff so that you can see how h of x changes compared to f of x, which is in red. So for h of x, when I'm at -2, that's +1. At -1, it's +2. 0, 0, 1, 4, and 2, 5. And I'm going to connect these dots from left to right. Now, when you look at this one, if I go from this point to this point, I've actually gone up 3 units. Same thing from here to here. I'm going up 3 units, going up 3 units, going up 3 units. Now, if it is a vertical move, then h of x is simply going to h of x is going to equal f of x, and then all you do is either add to it or subtract from it. If it shifts vertically, you just add. If it, let's see, it would be shifting vertically either way. If it goes up, which is a vertical move, if it's a vertical up, you add. If it was a vertical down, I would have subtracted. Like if my green graph had been, down here like this, had been shifted down, then that would have been -3. I would have had f of x minus 3 because it would go down 3. But this one went up. It went from red to green. The red moved up. So my answer here would be f of x plus 3. And that's transformations.